Hi there! So in this video I'm gonna talk about rotation mechanism and head movements mechanism. Just like the previous one, this one was shot a few years ago, so it gets awkward sometimes. But look, I was young, I needed money, so I'm comfortable with my choices. Enjoy! So, this is the main part of rotation mechanism. For a robot to be able to rotate on the spot, it is necessary that this part would be able to rotate independently of the rest of the mechanism, creating momentum. This is why the mechanism itself is mounted on the big lazy Susan here, which allows it to rotate. There are a couple of things to consider making this mechanism. One is the center of mass. The lower it is, the more stable rotation will be, and the robot will have less tilt from side to side. Another thing is weight. More weight means more momentum, which means increased probability that the robot will rotate smoothly. Now, with the center of mass, everything is pretty clear. This part looks like a dish, specifically to be able to be the lowest possible inside the sphere. If you look closely, you will see that this dish is made of 4 pieces. Each piece is made of plastic but is hollow inside, which allows me to put lead shot inside. In that way, all 4 pieces together will combine in the dish, and the total weight will be around 4.5 kilograms. Another question is, what will drive this thing to rotate in the first place? So, on the main mechanism, on the sides you will see there are 2 motors here. Each motor has a special rubber roller. The motors are located in such a way that the axis with the roller is pressed against the bottom part to be able to rotate it. To ensure optimum traction, I designed a special mechanism which allows to adjust distance between the axis and the bottom part. You can do it by pressing on this triangular part or adjust it more precisely with a screwdriver. And on the inner part of this dish, on this face, there are teeth just like on the sprocket. This is to increase friction and to help it to pick up the momentum faster. I haven't tested this mechanism yet and I don't know whether it's gonna work or not. So this is why the first thing to do is to assemble, but without the lead shot inside, and to see if it works. The mechanism is assembled and ready for testing. Connecting Arduino, waiting for a joystick to connect via Bluetooth, and connecting power supply. So this is the first test and it's a success. Everything works the way it was meant to work. Now we can proceed to the next step, which is to put some LED shot inside and to test this mechanism in full weight. Everything is working very smooth. Rotation is stable and controls are very sharp, both in slow and in fast mode. But before we move on to a dome tilting mechanism, we have a problem to solve. In the first video, I mentioned that the gearbox lacks necessary stiffness and sways back and forth. I decided to reinforce it with another plastic part. Let's see how it will do. Well, good news, the gearbox is working fine. Looks much better and without any tilting. Just listen to the sound of those gears. Apart from rotation, the dome should be able to tilt around the central axis. That is achieved by two plastic parts here. One is moving on the x-axis and the other is moving perpendicularly. Movement is done by two servos. Let's assemble the mechanism and test it. So the mechanism is assembled, so let's test it. It works perfectly, I think.
One eternity later.
So it seems that everything works perfectly, but there is one thing we need to do before we assemble and test it inside this sphere. Let's make sure that these servos can handle the stress and the load of the fully assembled head. So the next steps would be to print a dome and then assemble it and test the whole thing again. So, the dome is printed, and as I mentioned before, this mechanism involves magnets. I bet almost each of you played with the magnets as a kid. And maybe you tried to move a paperclip around without touching it. The principle here is the same. This is the bottom part. It fits here and is moved by servos. This whole thing sits inside the sphere. This is top part. It sits outside of the sphere and it connects to the dome and follows the magnets. But how the dome will move on top of the body without scratching the surface or getting stuck? This dome has a special wheel cart inside which allows it to move around smoothly in any direction. The trick is to find the right distance between two sets of magnets. Too close and the dome will stuck. Too far and it will always fall off the top. At first, let's see if the servos can handle the stress of just magnets. So, mechanism works and looks pretty well, but as you can see it wobbles quite a bit. This is because the servos that I got can barely handle the load. And on top of that, this servo holder is not rigid enough. So until I fix that and make it more stable, there is no reason to test it with an actual dome on top. So to make it more stable, I will have to replace these two servos here for more powerful ones, and then to redesign and print this small servo holder, because I don't like how it holds the servo, it's too wobbly. So while the new servo is being delivered, let's go to the next step.